Chapter 2.4, exact equations. So in the exact equation section, we have a very particular type of way to solve these types of problems. So what we want to do in the first step is verify that our equation is in the form some function of x and y multiplied by dx plus some function of x and y multiplied by dy equal to 0. Okay, so if this, for example, was a minus, it's a good practice to distribute the minus inside the parentheses so that you could leave the plus outside to really identify what's your m and what's your n. Okay, so first things first, we have to check out if it's in the right form. The second thing we want to do is take the partial derivative of m with respect to y, where this term over here is m and this term over here is n. Okay, so if I take the partial of m with respect to y, I see that I have a y squared term, and we're going to treat x as a constant in this case. Okay, so if I take the derivative of y squared, I get 4y. So this becomes 4 times x, which is a constant, times y. Okay, alternatively, I'm going to take the partial of n with respect to x, and in that case, I have over here x squared, the derivative of that's going to be 2x. So I end up with 4x times y, which is a constant when we take the partial with respect to x. What I want to do is verify that the partial of m with respect to y and the partial of n with respect to x is indeed equal. And because both of the partials are equal, we can say that this equation is exact. Okay, and so therefore we can proceed. From this, what we want to do is then calculate the integral of m dx. Okay, which becomes the integral of this portion here, 2xy squared minus 3 all times dx. And at the same time, let's also calculate the derivative of n dy. Okay, so right here we have 2x squared y plus 4 all times dy. And let's put this in parentheses so it's understood that the entire integral is being evaluated. All right, from here, let's take the derivative, the integral with respect to x. So this becomes x squared divided by 2, the 2 cancels. I end up with x squared y squared, and then if I take the integral of this, subtracted by 3x. Same thing over here on the y. I'm going to make this into y squared and divide it by 2. So I get x squared, which is a constant once again, times y squared plus 4y. Okay, so let's erase this portion up here just so I can continue the problem. We'll leave this down here. Now, it's important when you write the final answer of f of xy as equal to the summation of these two parts that we just calculated, but only writing the common terms once. So where you have an x squared, y squared, it also repeats over here. I'm only going to drop it down once here. So I end up with x squared, y squared, and then add the other terms that weren't duplicated. So I have x squared, y squared minus 3x plus 4y. And then finally, I can make this also equal to c, some constant or some function of xy. Either way works. And this then becomes my final answer.